Hello everyone and welcome back to our course on modern web development. In this lesson, we'll improve your AI-powered application by implementing responses from OpenAI's API, including streaming. By enabling streaming, your application will display AI-generated content in real time, providing a more interactive and engaging user experience. Before we dive deeper into how to implement streaming, I just want to show you a quick demo. So let's go to ChatGPT's website first and let's give it a random prompt like hey, write an essay about coding. And as you can see, it generates text in real time using streaming. So instead of just giving us one single response, it actually generates text using chunks and streaming. So yeah, that was a quick demo, and now we can actually dive deeper in how the streaming works and how to implement it. So let's close ChatGPT for now. And I would love to start with understanding streaming in OpenAI's API. So what exactly is streaming? We're going to compare standard responses and streaming responses. So in standard ones, the client sends a request and waits for the entire response before processing it. And in the streaming responses, on the other hand, the server sends data in chunks as is generated, and the client processes and displays data incrementally, so in real time basically. And some of the benefits of using streaming responses over standard responses, that it improves user experience by reducing perceived wait times. So imagine we want ChatGPT to write us an essay, and using standard responses we'll have to wait like a minute to get the response, while with streaming responses we can get text in real time. So yeah, it improves user experience. Also, it improves interactivity. It makes applications feel more dynamic and engaging, as well as visual appealing. We can't argue this. And also efficiency. It reduces memory usage by processing data as it arrives on the server and on the client. And once again, streaming responses allow us to provide immediate feedback to users by displaying the AI's response as it being generated. And this mimics natural conversation and enhances the interactivity of our application. And now we're going to move on to implementing streaming in Next.js. So we're going to enable Edge Runtime first. The Edge Runtime supports streaming responses and offers low latency execution. And also we're going to modify the API route by implementing a transform stream to process the stream data from OpenAI. We're going to simplify the stream logic to directly pass processed content to the client. And we're going to improve error and mistake handling and set appropriate response headers. And before we dive deeper, there are a lot of ways how to enable streaming in our applications. For example, using Vercel AI SDK, which we can also explore later in the course optionally, but we're just going to start with the optimal solution. Update your code in app folder, API folder, generate folder, and within route.js. So we're going to copy the starter code, and I'm going to explain it right now, so just hold on a second. Navigate to your code editor of choice. Of course, I'm using Visual Studio Code, since we already explored it in our previous lesson when we made our first AI text generator. So let's go to our route.js and simply paste this code right here, and I'm going to explain it now. So first of all, we specify export const runtime equals to edge to enable the edge runtime, allowing for faster and lower latency streaming responses. After that, we fetch from OpenAI API. So we send a post request to OpenAI's chat completion endpoints with stream equals to true to enable streaming responses. After that, the request includes the model here, so GPT 3.5 Turbo. You can use other models such as GPT 4o. Also, we specify messages, so we give it a role of user and content of prompt. Also, we give it a temperature of 0.7 and once again streaming option. After that, we enable some error handling, so we check if the response from OpenAI is okay. If not, we throw an error, so right here. And we wrap the entire application in a try catch block to handle any exceptions. So right here, our try block starts, then we have the catch. And after that, we basically process the stream. So we use the transform stream. We create a transform stream to process incoming data chunks. After that, the transform function is called for each chunk received from OpenAI. After that, we decode that chunk, split into lines, and process each line individually. And also lines starting with data contain the actual content. And we parse the whole application and data to extract the generated text content. And we enqueue the content to be sent to the client. And if we receive done in the brackets, we exit the function to stop processing. And once again, we return the response. So we return a new response object with the transform stream. So right here, we set appropriate headers to indicate that the response is plain text and that we should not cache it. And a small note that by using the transform stream, we efficiently process and forward the stream data to the client, enabling real-time updates in the front end. And now I would love us to understand what is transform stream in depth. So a transform stream is a part of the Web Streams API. It allows you to read data from a readable stream, transform it, change it, and write it to a writable stream. It consists of a transform method that processes each chunk of data. And why would you even bother using the transform stream here? So first of all, for efficiency, also real-time transformation. It allows us to modify and change or extract necessary information from each chunk before sending it to the client. And also it's simple. It reduces complexity in handling streaming data compared to manual buffer management. And some of the key components of transform method. So first of all, it's transform method, which invoked for each chunk of data received. It decodes the chunk and processes it line by line individually and extracts meaningful content and enqueues it for the client. After that, we have text decoder, which converts bytes into strings. Also, we have text encoder, which converts strings into bytes and used to handle data in the stream. We also have controller methods, controller.enqueue, for example, which adds new data to the output stream. We also have controller.error, which signals that an error has occurred within the transformer method. And we also have transformer.terminate, which stops the stream immediately. So using the transform stream, which allows us to process each chunk of the data as it arrives from the OpenAI API, we decode the chunk, parse the JSON data, extract the content, and then enqueue it to be sent to the client. And this approach ensures efficient real-time streaming without unnecessary overhead. And now we're gonna update the front end in real time. So we're gonna update the code, the front end, to handle and display streaming data by reading and appending chunks from the response as they arrive. So let's go to our page.js right here and simply paste the code from our lesson. So this right here. And after we pasted the code, I'm gonna walk you through it because it's kind of long. So as an explanation, we import useState from React to state management right here. We also import icons from Lucid React to improve our visual feedback. And after that, we have some state variables such as prompt, set prompt, response, loading, error, and copied, which indicates if the response has been copied. After that, we have handle submit function, which prevent default behavior. So we prevent the default form submission to handle it manually, and we clear previous responses and errors, set loading to true, and also we set error to null, so clear any previous errors. After that, we fetch request. We send a post request to our API route in API/generate with the user's prompt. And after that, we check if the response is okay. If not, we throw an error with the response text, and we get the reader from res.body to read the stream, and we use a loop to read chunks. So yeah, right here we use a loop from the stream until it's done, and each chunk is decoded and appended to the response state. And any errors are caught, logged, and displayed to the user, and we set loading to false after the operation completes. Also, from our previous lesson, you might remember that we have copy to clipboard function, which copies the response tag to the user's clipboard so we can use it elsewhere. And also, we apply some styling in the end, so we use Tailwind CSS classes for styling components, and we ensure that application is responsive and visually appealing to users. I understand there are a lot of informations, but once again, you can refer to OpenAI API reference or our lesson, which has all the code broken down with all the nodes right here, so you can refer to that. Some of you may not fully capture the code, so I will just show it here slowly so you can follow along and catch up. That was the route.js, and now we'll go to our page.js. So I'm gonna scroll slowly and you can just pause. And now we're gonna test and validate our application by running npm run dev. So let's go to localhost. And now we have our AI text generator by Nozomio. So what to look for, the AI generated text should appear incrementally, simulating typing. We also should have loading indicator, error handling, and performance. The application should remain responsive during streaming. So now let's actually test it by running the same command as we did to ChatGPT. So write an essay about coding. And as you can see, it generates text in real time by using streaming, so it actually writes the essay on coding and it works perfectly. And I also want to discuss some best practices and considerations for using this. So make sure that processing data arrives and minimize memory usage, and also avoid unnecessary re-renders by optimizing state updates. Also, make sure your API key protection is valid, so keep your OpenAI API key secure using environment variables, and do not expose it in the client-side code or commit it to version control. Also, ensure that the features used, such as Fetch API with streaming, are supported in target browsers, and provide alternative behaviors for browsers that do not support required features. And some of the ethical considerations would be implement checks to filter out inappropriate or harmful content if required, and also monitor API usage to manage costs and prevent abuse. We're gonna dive deeper in how to monitor our usage in the next lessons. So yeah, and one more note that adhering to best practices ensures that your application is secure, efficient, and provides a high quality user experience. So let's go back to our lesson first. Great job today, guys. In this lesson we've implemented streaming responses in our Next.js application. We modified the API route, updated the front end to display AI generated text in real time. We enhanced the user interface with some Tailwind classes, and we ensured code follows best practices for performance and security. In the next lesson, we'll explore more about enhancing our app, such as we're going to implement authentication databases using Prisma, probably, or SQL, and more to secure our applications and personalize user experience. And if you have any questions or need assistance, feel free to reach out if you have any problems or you're stuck somewhere to our team using social media. And once again, thank you for participating and happy hacking.